Thanks a lot, everybody, for joining. I'm Yury, and let's talk about test-driven infrastructure. So, quick background about myself. I have a mixed background of quality assurance, software engineering, system engineering, and SRE, site reliability engineering. My main focus is on distributed systems, open source technologies like consuming and contributing back, and reliability at scale. I'm originally from Russia. I started my career there in a Russian investment bank, then relocated to Czech Republic in Prague to work for major Linux distribution of SUSE Linux. Then moved on to GoodData, big data analytics company, where I was running OpenStack and huge scale production, and I also had the luck to build a Kubernetes production cluster for iFlix entertainment platform for more than 5 million subscribed users. Currently, I'm an architect for site reliability engineering in McKinsey company, where I'm busy with a variety of SRE-related projects. So, what actually to expect from this talk? So, as I lived through the challenges and pain of testing distributed systems, I will try to share a couple of real-life stories with you on infrastructure testing and infrastructure development process evolution. The focus will be on testing infra at scale, and I will provide like a set of opinionated tools. Meanwhile, this set will be flexible enough to be adapted for your specific case. Unfortunately, not a talk about Kubernetes, sorry, not trendy enough, but I try to compensate it with my KubeCon t-shirt. Meanwhile, if you are actually running Kubernetes, the talk will be still relevant if you are dealing with a hard layer of virtual machines and if you're building your own Kubernetes cluster. So on this layer, the talk is fully applicable, and also if you are running a diverse environment where you have not only containers but also VMs, which is still pretty frequently the case, the talk will be also good for you. So quickly on prerequisites and overall terminology as a background for the talk. So pretty frequent is to reason of mutable versus immutable infra. Does this stuff work? Yeah. Okay, mutable versus immutable. So what we are meaning here? So mutable, we assume that we already apply configuration management code. Everything is Git version control, everything is good, and automatically applied through CI/CD. Meanwhile, if we are doing so-called in-place updates on running servers, we are going through these transition states here. So we have a permutation, and it's not so reliable by design. We have so-called high probability of configuration drift. So that's why immutable pattern has more reliability in mind, where we actually, instead of performing in-place updates, we are replacing the full instance. And practically, it would look like you build a VM image and test it properly, and then replace the server instance during the delivery of update. Actually, there can be like no configuration drift, but in practice it's more like minimized, because we still have a form of user data which depends from specific configuration. It can be kind of volatile. It still propagates some variables into booted up instance. Still, the drift is seriously minimalized comparing to mutable scenario. And for the rest of the talk, we assume that we practicing infrastructure code, we have a mature team, everything is Git version controlled. It doesn't matter if you practice Puppet, Ansible, Terraform, whatever, but we have a already strong infrastructure as a code as a strong prerequisite. So, story number one, mutable infra, Puppet-based in GoodData. GoodData is a big data analytics company that I used to work for. A bit of background on infra itself. So OpenStack-based infra, private cloud, pretty huge scale of hundreds of physical servers and really thousands of VMs, multiple data centers around the world, and relatively pretty huge Puppet code base. More than 150 Puppet models, everything in single repo. More than 100 service types. Service types here, it's like a way to compose these Puppet models. Basically, each model was responsible for specific stuff, like web server, backend, whatever, and this service type was commanding, through single environment variable, was commanding what to actually server to converge which type of instance. It can be front-end, backend, and any piece of distributed system. So we had a lot of them. This brought kind of reliability problem in a form of tightly coupled models with multiple interdependencies. And yeah, infrastructure as the code itself had quality problems, and operations had reliability challenges because of this pattern. So it was amazingly automated. Meanwhile, we had these huge scale challenges. Just to depict like a snapshot on Puppet dependency graph like 2 years ago, more than 2,000 resources, more than 7,000 dependencies between them, so quite a beast. It was very first our naive approach how to approach the testing itself for infrastructure as a code. So check out new Puppet code, meaning like new Git branch, like PR branch, for example. Run the execute draw run with no op. Evaluate the output, like if it seems safe. So it looks like it doesn't change something that we don't want to. Then execute actual Puppet code on the target instances, and then perform manual smoke testing. So very trivial. Obviously, doesn't work reliably at scale, very human dependent, and not really automated. So we found a great tool called Test Kitchen to actually mitigate and solve the problem for us. So what the Test Kitchen is, so you can visit Kitchen CI. It has a sexy slogan, your infrastructure deserves test too. We can call it like advanced test orchestrator, where we compose the test kernels for us. Fully open source, actually maintained by Chef and its wonderful community. Very pluggable on all levels. It stands for its flexibility and so on. Configuration is a breeze, simple readable YAML file. Simple, clear architecture of the tooling itself. So the main entities, main parts of the kitchen is driver, provisioner, and verifier. So main verbs like driver creates, provisioner converts, and verifier verifies, obviously. What actually happens is that the container or VM or whatever test instance is getting created for your testing scenario, configuration management code is getting applied. Meaning like instance is getting converged to the desired state, and verifier runs the test framework that you're going to use to actually verify the expected result for the previous step of configuration management application, if it actually configuration management code delivered the desired stuff. So a bit dive into each of them. So driver, obviously, hypervisor, container cloud to use for your test harness. A lot of driver plugins is just copy-paste from official documentation. There's actually more. Really good span over private cloud, local scenario, and public cloud. Provisioner, configuration management tool to apply. And again, a lot of provisional plugins. The most prominent configuration management solutions like Puppet, Chef, Ansible, SaltStack, and most modern one is Terraform. For verifier, it's actually a tiny layer between the kitchen and the test framework you're going to use. And again, a very good support of community frameworks. So starting with bets unit for simple shell-based framework, continuing with Ruby RSpec and infra testing derivatives like Serverspec, Inspec, and Ansible spec. We'll cover them later. Powerful CLI. So actually, for every action that kitchen supports, you can run a kitchen create to command driver to create the instance for you. You can run kitchen converge to apply the configuration management code under test, and verify to run the test framework for to check the expected result. Each of the actions are actually sequential, so you can just click verify, and it will automatically invoke create and converge states for you. Kitchen login is worth mentioning because whenever you have problems with test or the configuration management code itself, you can log into instance under test and debug and investigate in classic way in a shell. It's very convenient. So as was mentioned, there are a variety of plugins, so we need to come up with a specific way of running the kitchen. So in GoodData, it was a combination of Docker driver, Puppet provisioner, Serverspec verifier. So speaking of Docker driver, so here and there I will show you configuration, actual kitchen and specific Models configuration, just to give you a feeling how it is easy to configure it. So kitchen Docker is separate model. Currently, it's actually merged to a test kitchen core. Configuration is, as you can see, pretty straightforward. You name is the driver, you point into an image, there is some additional supporting directives, and basically you have it working. Additional features that was mentioning, just to demonstrate that you can basically control any kind of Docker capabilities, what Docker functionality through a simple YAML, like mounting volumes to your testing container, adding kernel capabilities to enable not a full privileged container, but finally grained kernel capabilities to limit the exposure only when you need it. And by default, kitchen Docker generates this testing container dynamically, including Docker file for you. If you want to have a power of customization, you can totally override it and adapt it for your specific scenario. So it's really flexible. So actually, why Docker driver? So again, GoodData is an OpenStack shop, so OpenStack driver would be most obvious thing to use. And there is definitely OpenStack driver in Test Kitchen. But for us, it was pretty resource demanding to use VMs for a test harness, and also it was super slow. So that's why we tried to stick with a containerized version of things for a testing scenario. As a good side effect, we got a shared testing environment between developer and CI/CD, because it's all wrapped in kitchen in both cases, and it's easier to reason and debug what is happening in CI if there are any issues. And it's important to mention that actually these are system containers, not application containers. So these are system containers that are created for testing and mimicking virtual machines or servers and related configuration management code under test, meaning that they're running such unusual things like a init process inside, and they are really mimicking whole operating system. They're created for this testing scenario. It's not application ones. So obviously nothing comes for free. We had Docker-specific limitations and deviation from real VM scenario. For example, like even if your Puppet code does something super privileged, it's gonna fail, and so on and so on. And we also faced pretty hard to debug issues, which are mostly were related to the fact that users are not properly namespaced in the user kernel. And when you, for example, running several testing containers on a single Jenkins slave, they can fight for sources, they can fight for security limits, and it was not that obvious what is happening. But eventually we mitigated that. So for Puppet provisioner, so we were running Puppet. Obviously, Kitchen Puppet is a way to go. It's a standalone project. It's important to understand that in Test Kitchen there is a very diverse community. So part of the things are really core, or like Test Kitchen core, and part of the models as well, like Kitchen Docker above. But Kitchen Puppet is completely different maintainer, completely different people. But meanwhile, everything is pluggable. Very simple mission: upload Puppet code into instance under test and getting it to converge state. Very powerful thing is that you can control with this provisioner testing constraints by overriding the custom Puppet facts. And here is an example, like apart from obvious Puppet configuration, you can see the ability to override the custom facts that are specific for your code. In the GoodData scenario, it was like in a single environment variable, a fact that I mentioned before. We can control actual server type to make Puppet code path executed in a specific way. And there are additional bunch of additional supporting the directives, like for example, custom install command. So testing challenges. Obviously, Puppet doesn't work out of the box in that scenario, so we had a bunch of external dependencies and the above mentioned Docker limitations. So we decided to try to mock and stop CLI that Puppet invokes in these special edge cases, and it wasn't that obvious in the beginning. So that's why we had to create a simple tool called shellmock. We open sourced it a couple years ago, which handles this dependency injection situation. So basically, it's install a mock instead of executable that you want to mock. It hooks into Puppet run, and it ropes package manager, like intercepts the call to YAM, for example. And if the mock is configured, it's gonna install the mock instead of actual binary or executable. And by itself, it has own simple YAML configuration. This simple YAML configuration is super straightforward. So actual package pass to executable to mock and contents of this specific mock. If we do not specify any content, it's just going to verbosely log I'm fake something and exit 0, so Puppet can proceed with the converge. So we have control over this mocking and stubbing. Couple of examples. So this is IPA mock. So IPA is kind of open source Active Directory alternative. So we don't want to register container every time we're running testing. We execute and test run, obviously, it would be a huge overhead and basically create a mess and make it slow. So that's why we can create in a simple mock that would write the fake data into specific configuration files. And that's pretty it. So we again, define the package, define the executable, and define the mock, and the resulting mock is here. It's just a simple bash script that does the job. An example of stub is SSSD. We don't care what will be there. We just want to exit 0, and just for login purposes, the tooling will generate this simple stub. So this way, we are getting rid of external dependencies and have it the test run faster, isolated, and reliable. Serverspec verifier, so actually is a part of testing framework. Serverspec itself is standalone project completely, but it's nicely integratable. It provides domain-specific language to express your desired configuration state. It has a pretty rich resource library out of the box, so which provide nice abstraction over things under test. And it's very agnostic to any specific configuration management solution. So be it Puppet, Ansible, whatever, you can test them all. Couple of DSL examples. So you can, if you ever wrote our spec test, it will be very familiar to you. We have like the describe command, a resource, and within a do and block, we build an expectation. So you just randomly pick resources. So you can test the file state, routing, container runtime, some port if it's opening on which type of protocol, C groups, and the command one actually deserves special attention because you can put any command there in a command resource and build any kind of expectation for std out, std error, and exit code. Meaning that you can create a powerful test for your specific case, even the resource is not abstracted in a core DSL library. So it's really powerful and flexible. So obvious questions that is frequently discussed, how to test, what to test, and why to test. My personal trick and recommendation is I anyway deploy the stuff, deploy the distributed system and services. I always try to think what I would anyway check to verify system stability and healthiness. Then I express in testing DSL Serverspec in that specific story. Sometimes, test the outcome is a nice pattern. So meaning testing the outputs, not only the inputs, meaning basically testing configuration, like some configuration file is containing some expected data is useful static test. Meanwhile, accompanied output end-to-end like test is even more powerful. So you can check that the service is returning expected HTTP response on a specific URL, on specific IP endpoint, and so on. And I really recommend to keep it simple, or keep it practical, and not writing tests for the sake of tests, but really writing tests for the sake of reliable delivery. That usually works. This way, you will have a minimalized test suites, very clean to understand, clear to understand, and easy to maintain. So the example of testing the outcome that was mentioned. So here we have a simple test of checking that web server is actually under Kerberos authentication. A little bit of Ruby just to iterate over the array, not to copy paste the tests. And we have super simple expectations combined, created with this common resource, where we checking that URL under investigation is redirecting. So because it's HTTP, it's expected to redirect to HTTPS. And actual HTTPS endpoints are under 401 authorization required, practically meaning that Kerberos is kind of configured. So super simple, meanwhile effective. And you don't need anymore to having this test. You don't need anymore to check it manually. So worth mentioning the special meta structures in Kitchen YAML like platforms and suites. It allows you to create multiple test combinations, the test configuration within a single configuration file. Platforms are used to usually like to depict the distribution or image under test overall, but you're not limited for this specific scenario. Suites are reflecting test framework semantics. Important things that like you have configuration for driver, provisioner, verifier, and then on the level of platforms and suites, you can override the specific points that are specific for platform or a suite. In this example, this is a real configuration where in GoodData it was a migration period from Enterprise Linux 6 to Enterprise Linux 7, and we had to verify that both that our Puppet code base operates reliably on both platforms. So here we created EL6 platform pointing to specific EL6 image with specific kernel capability, which was useful for most of the cases for EL6. Meanwhile, for EL7, we are able to use different image. We use different Docker file to actually incorporate specific things to enable systemd running inside a container. So remember that it's a system container, and we had to do some tricks to actually make a systemd running there. Wasn't that trivial in the beginning. So for suites, it's again semantics of test run. Again, ability to reopen the configuration of specific stuff like provisioner. Here we override the custom facts and we commanding the suite that it's gonna be front end. Same for backend, for example, and for the case of database, we also reopen drivers, so we can add the specific kernel capability cap resource, so PostgreSQL actually is capable to work within a container. So everything's customizable as much as is demonstrated. When you're running kitchen list on a similar configuration, you will get actually test matrix here, which kind of multiplies the suite on a platform. So you have a suite and platform combination, suite and another platform combination. You can test them all simultaneously, or you can run them in isolation, whatever you like, how you want to plug into your CI/CD. With that in mind, and when we have this set of tooling, we can actually create a very nice process of test-driven development for infrastructure code. So imagine like we writing expectation in testing DSL, Serverspec in this specific story. We running verify. We observing that this specific test is failing because we do not have configuration management code to satisfy the expected result yet. Then we writing this configuration management code to actually implement the expected feature. We running kitchen converge to reapply the test configuration management code on an instance under test, run, execute, verify again, and we observe that test is green. So here we have a pretty classic red-green refactor TDD process, which is reasonably popular in software development community and overall software engineering. So for CI/CD point, thanks to the powerful CLI, Kitchen is easily pluggable into any CI/CD solution, Jenkins, Circus, whatever, doesn't matter, because you can invoke these things anywhere. Important point on a test suite itself, though, is that you can reuse the same test suite all the way from development to production, so on the developer laptop, CI/CD pipelines, and actually post-production monitoring. So here's a slide from my presentation at LinuxCon a couple of years ago. So what we had, this is kind of simplified picture of our pipeline back there. First, we had this static code lint checks for a Puppet code to fail fast. Then we had a promotion to test kitchen stage. Here we had a Puppet, Serverspec, and shell mocking. If the tests are fine, then code was automatically merged into target branch and promoted to staging cluster. This time, obviously, without the shell mock. Meanwhile, Puppet and Serverspec test suite and code under test are exactly the same, and then if everything is fine in staging, they promote it to production as well. And the trick here is that Serverspec test suite is actually hooked into monitoring solution. So whenever we have a configuration drift, test suite is going to catch it even after release. So it proved to be very powerful, especially in this mutable kind of infrastructure style. So with that in mind, story 01 recap. We have Test Kitchen as a very extensible test orchestrator. We have a very powerful process of TDD for infrastructure. Thanks to this process, which is continuously repeatable by engineering teams, we have a naturally growing regression test suite because every PR is supported by every configuration management pull request is supported by related test code. And the whole stuff is easily pluggable into CI/CD of any kind, and whole things is open sourced. Story 02. Actual immutable infrastructure in Terraform in completely different company of Quantum Black, which is also analytics company. Currently, it's a part of McKinsey & Company, my employer. So a little bit of environment. So AWS, HashiCorp, Packer for AMI, image building, and a Terraform to actually execute this immutable infra pattern. Obvious testing challenges. We need to verify that AWS resources are configured correctly. Because we're practicing immutable infra, configuration of the image becomes really crucial, and the overall image release churn is higher velocity. And related to AWS resource, we overall need to validate that Terraform code under test behaved well. So again, Test Kitchen. But this time, configuration is completely different. So there is yet another community project called Kitchen Terraform. Usually, these community projects provide driver, provisioner, or verifier. This is kind of good exception, a very nice exception, I would say, which provides all of them, and a very nice integration of driver, provisioner, verifier that are targeting Terraform, and verifier is effectively Inspec. We will talk about in a minute. For provisioner, it provides very nice ability to override Terraform variable files to create these testing constraints, and to create test fixtures. Test fixtures are basically the Terraform code that is created only for the sake of testing. It usually just includes your Terraform models under test, and it's hooked into this Terraform provisioner invocation. And the integration of provisioner and verifier is very helpful because you can propagate Terraform outputs into the tests themselves, meaning that, for example, classic thing like volatile instance ID from AWS, instead of creating some filtering based on a specific text and so on, you can just propagate the freshly created instance under test ID and create expectations on top. I will demonstrate a couple of examples really soon. And speaking of Inspec, it's very similar to Serverspec, but it's actually a fork which was created roughly a couple of years ago by Chef. It is actively maintained comparing to Serverspec, which is kind of passively maintained. In these couple of years, they managed to create a lot of resources, so they more than doubled the amount of resources in Inspec comparing to Serverspec, and it provides powerful CLI out of the box. Serverspec provides you only DSL library that you can kind of include into your Ruby stuff, and the structure of test suite completely on you. That's why in GoodData we had to create this CLI inside for our specific purposes. Here it's part of the project and it's really convenient. It provides a nice way to run the tests, provides you test suite structure to reflect on them, to test the tests themselves, and reading documentation and see in command line is pretty powerful. So yet another spec-based framework in this story is AWS Spec, which is just to create expectations for configuration of AWS resources that you are interested in. And it is nice that we don't need additional verifier. We can reuse AWS Spec from inside Inspec because it's yet another Ruby gem, another Ruby library. So to the examples. So here we have a actual suite combination. We have a two types of test suite. One is AWS targeted, and another into E-like test, like testing that.com, like I mentioned in the previous story. For these attributes, we can actually propagate the Terraform outputs to actual variables in the test suite. So this is Inspec example that comes next, and it relates to this chunk, to E2E and smoke test with a control. So first we propagate the actual Terraform output attributes as Ruby variables inside the Ruby test code, and we have a Inspec control called smoke, which is associated here, and we can create a simple expectations. So we have this propagation from the Terraform, and we can wait for with a threshold thanks to Serverspec wait for 3 minutes. That actual health endpoint is returning status code 0. If you remember in Serverspec, I had to use curl and command. Here in Inspec, we already have a nice resource abstraction of HTTP that we can use. The same, similar a couple of tests for other type of server where we test the redirect and the expected location of redirection. So pretty straightforward. Example of AWS spec inside Inspec. This is related to the first control chunk and a kitchen YAML related one. And again, we getting this volatile Terraform outputs into our tests, and we requiring AWS spec library, RubyGem, and we creating expectation around these instances in this specific example. So we checking that instances exist after the execution and that it has specific pair of text like capabilities that these are very specific to our project. So AWS and Terraform are covered. Still, Packer is a crucial part because again, immutable infra, we need to test the images. Quickly on Packer setup, obviously AWS builder in that scenario, so we create AMIs. And for provisioners, these are provisioners not the kitchen ones, but Packer provisioners, so terminology intersection. We use shell, simple shell, or Ansible provisioner to configure the image during the build, depending from feature to feature. So how to test that? Kitchen setup for Packer. Again, same test kitchen, but different configuration. Kitchen EC2 is a distinct driver, so we can boot up these images under test quickly for in AWS. A shell provisioner this time is test kitchen provisioners. Shell and Ansible to actually apply this configuration management code under test, and a standalone Inspec verifier to reuse the same Inspec, similar Inspec test suite, but without Terraform integration on an image building stage. So basically, story 0 to recap. We can use test kitchen for completely different environments and even the infrastructure type, both mutable and immutable. However, same TDD this time for immutable infra, so you can apply TDD both for image building with Packer and for actual Terraform code. And a switch to more modern infra tooling and a more modern test framework was like a breeze, very easy, thanks to these community projects. A couple of fundamental remarks on testing in CI/CD, which are pretty basic, but it is important to mention them. So it's highly recommended in this scenario to put linting and static codes like quick tests as a dependency in a pipeline. So you actually block the pretty heavyweight test kitchen execution. No matter if it's container based or VM based, it's still heavyweight compared to static linting or this kind of lightweight validation. So spend your resources wisely. For immutable infra, overall concept is really, it's not only creates a reliability in for operations, it really simplifies the testing of the infrastructure in its code. Mostly because two things, we deploy exactly what we test, and we don't need to test this transition from one stage to another. Every time we deliver the update, we have the pre-tested state in the image. We don't need to test the transition at all, so it simplifies the things. And promotion of immutable artifacts is a kind of core rule of continuous delivery. Quite frequently forgotten, and sometimes it's hard to practice actually. But in the case of AMI of a virtual machine image, the idea is that you want to build an image under test only once and then promote it without rebuilding on consequent pipeline stages. The idea is that, again, we test exactly what we deploy. and we do not impose the risk during the rebuild on later testing stages. So really build once and then test it and promote it over your pipeline down to production. So overall recap, same pluggable tool to rule them all. So really Test Kitchen is that flexible and amazing. A very powerful thing that it's totally agnostic to everything it operates with. So it can be adapted for any kind of environment, be it cloud or prem, private cloud or public cloud. You can use whatever configuration management you want, so Puppet, Ansible, or Terraform, or anything else. Test frameworks is the same, so you can plug in Serverspec or Inspec, or you can plug in other things like Test Infra or GOS. There are also verifiers for that. And overall, test-driven development flow is being practiced continuously by your teams, can really reduce overhead and catch reliability issues very early and less costly. So I would like to end my talk with this kind of promotion material from Google. So these guys actually put these kind of posters even in restrooms in their offices to kind of imprint the testing and TDD requirement and promote testing, the need of testing to engineers. And in context of this talk, we can take it a bit further. So manual testing sucks, automated testing rocks. Thank you very much.
Okay, we still have time for questions. So first one is here.
You said that you are using Docker for tests of mutable infra. Did you try with LXC or LXD? Because
no.
For me, okay.
Oh, only Docker.
Because
yeah.
for me, just converting Docker images was just too difficult, and we found out that LXC is much easier and much better performing than Docker.
You mean like for system containers, right?
Yeah, it was 2 years ago, so it's different now.
Yeah, we kind of early evaluated that, but for us, one of the motivation was to use Docker because Docker is probably already configured on developers' laptops. So we have this shared testing environment between laptop and CI/CD. So it was kind of strong benefit.
Okay. Any new questions? Okay.
Maybe loosely related, but you have mentioned that you were monitoring configuration drift on mutables infrastructure. How did you do it? Could you elaborate a little?
Yeah, sure. It basically was a hook in a Serverspec, like basically cronD, that was hooked into a Singa, like a Nagios fork-based system. And whenever the test suite, which was applied on schedule frequently, was failing, then we got an alert. That's simple. Yeah.
Anyone else?
One more thing, because the Test Kitchen has the suites and platforms, and with you had only 2, like in Enterprise Linux. How many systems did you require to support in suites and platforms?
Well, in both kind of cases, we were only sticking with a single Linux distro. So I demonstrated this EL6, EL7, but it's only for migration. So usually from really like clustered understanding of platform, it's only single one. Because in a case of startup, you're usually using like one single distro to operate. If I would be, I don't know, kind of integrator, I would create more platforms, obviously, and it's pretty easy to do.
So because you said that you had about a lot of Puppet modules, yes, or roles, I don't remember. So did you test each role separately, or just a bunch of them together?
Well, we initially we had this bunch, but we optimized it by so-called Puppet diff. So whenever pull request was created, the Puppet catalog compilation was performing in the very first stage and compared with the previous promoted catalog. So with that, we got a reliable diff of what kind of types were changed, and we execute only relevant types that are affected by this change. That's a great question.
I see no more questions, so let's thank you, Yury.
Thanks a lot, everybody.